How we doing, everybody? This is That Our Nerd back at it again with another algebra tutorial. This one today is going to cover properties of real numbers and the different properties and whatnot. And we'll cover those in a minute. But as I've been making these videos, I've realized math's a little fun. You know what I'm saying? You know what I'm saying? You feel that a little bit? Feel that math positivity just blowing through your speakers right now? It's incredible. All right, let's go through some properties here. So I'm not going to write the names out because my handwriting on here is terrible. But our first one is the commutative property of addition. So if we have A plus B, we can switch the order around, right? This would be the same thing as being B plus A. That would be the same exact thing. So you can switch the order when you're dealing with addition, and that is called the commutative property of addition. The same property, commutative property, except for multiplication. So basically means the same thing, right? So if we took A times B, that would be the same thing as doing B times A. So it's commutative. You can switch the order on these. We also have the associative property of addition. So this is saying if you had A plus B in parentheses, right? So normally you'd have to do these first and then add C, right? So if you had A plus B in the parentheses, this would be the same thing as doing A plus B plus C. So with addition, you can move around the parentheses a little bit. The same property, again, goes with multiplication, the associative property of multiplication. And so this says if you have A times B times C, this is going to be the same exact thing as doing A times B times C. So again, you can move the parentheses around a little bit with when you're dealing with multiplication there. The last one is called the distributive property. You guys have probably seen this before, but if you had A and you multiplied that by B plus C, what you do is you distribute this A throughout both of these terms here. So you do A times B, so AB, plus A times C. So you multiply both those values by A, and that would be the distributive property. So something we can do with the commutative property of addition is we can move these around and combine like terms here, right? So even though we're doing 3x y squared minus 3x y x squared y, right? Even though these aren't the same, we can kind of rearrange stuff. So we'll start with our 7, right? And so we want to combine like terms. So we can move, with our commutative property, we can move this 6 over. And really, you could just do this in your head, but just to show, right? So we do 7 plus 6. Those are like terms. When you're combining like terms, you have to make sure that you have the same base, right? So this part of your exponent is the base, and the same power. So these have to be the exact same if you're trying to combine something. So x squared y could not be combined, right? We could not combine that with xy squared because we have different exponents in our variables. But we could combine this one with this one, right? Because we have x squared y in both of those variables there. So we'll do minus 6x squared y. And again, you could just do this in your head, right? You could say negative 6 minus 3 is negative 9x squared y. But just to show why it is we can do that, and these different properties that we just covered, I'm going to write these out again. So then we have xy squared and xy squared here. So I don't know, put a box around these, I guess. So the positive 3xy squared minus 4xy squared. And finally, at the end, we have our x terms. So we have negative 3x plus 5x. And so now we can go pretty easily and combine our like terms. So we have 7 plus 6 is 13. We we have negative 6x squared y minus 3x squared y. So negative 6 minus 3 is negative 9x squared y. We have 3xy squared minus 4xy squared. So we have a positive 3 minus 4. It's going to leave us with a negative, and you could write a 1, right? Or you don't really have to because it's kind of implied if you don't write anything. So negative xy squared. And then we'll do negative 3x plus 5x, which is plus 2x. Most of the time, teachers are going to want this in order of descending power. But I'm just going to leave it like this. Now what the heck. We'll do negative 9x squared y minus xy squared plus 2x plus 13. So again, we're able to switch the order of these because of our associative property. And most of the time, teachers are going to want with the highest power. Right, so we have a power of 2 and a power of 1, so the power for this term here, right, terms are split up by plus and addition signs. So we have 4 terms. Then the power for each term is just the sum of your exponents. So this would be a power of 3, this would be a power of 2, or 3, right, because we have x to the 1, y squared. This would be a power of 1, because we just have x to the first power, and this would not have a power, because there's no variables on it. And so you want to do it in decreasing order of power. Okay, hopefully this video was of some help to you. If it was, make sure to put an associative property directly onto that like button down there so that other people can find this video as well. Subscribe if you want to see more incredible, just incredible math skills and lessons from me. And if you've made it this far, I'd just like to tell you to have a wonderful day, okay? You're awesome, so stay awesome, all right? Thanks.